What are the chances that two stars would erupt into naked-eye brilliance, two powerful earthquakes would rip open Venezuela's crust, and a rare interstellar visitor would be struck by a solar storm, all inside a single 72-hour window? If this were a Hollywood pitch, producers would laugh it out of the room for being too far-fetched. But it's not fiction. It's real life. And reality just staged one of the most synchronized cosmic performances modern astronomy has ever recorded. After what unfolded, even hard-nosed skeptics are beginning to question whether we're seeing mere coincidence or something far stranger. Tonight, we're breaking down every piece of this story. The stellar eruptions, the double quakes, and the interstellar traveler battered by our sun. We'll dig into the science, unpack the timelines, and wade into the uncomfortable zone where coincidence starts looking like pattern. Stay with me until the end, because what's happening in September 2025 could upend everything we thought we knew about the forces shaping our solar neighborhood. Part 1. A chain of events. Too wild for fiction. Two stars exploding into visible novas. Two major earthquakes cracking the ground beneath Venezuela. And an interstellar object, the third ever detected, caught in the path of a coronal mass ejection. All within days of each other in late September 2025. If you feel like the universe is trying to get our attention, you're not alone. Let's map this week's cosmic collision with precision. On September 23rd, astronomers spotted V1935 Centauri, a nova brightening to magnitude 5.8 in the southern constellation Centaurus, visible to the naked eye. Days later, another stellar blast, V7994 Sagittari, erupted at magnitude 6.2 in Sagittarius, blazing just bright enough for backyard stargazers with dark skies. Meanwhile, thousands of miles away from the nearest observatory, the Earth itself was making headlines. At 22:21 UTC on September 24th, a magnitude 6.2 earthquake struck 24 kilometers east, northeast of Mene Grande, Venezuela, at a shallow depth of 7.8 kilometers. Hours later, at 3:51 UTC on September 25th, a second quake, magnitude 6.3, tore through the same region at 14 kilometers deep. Twin stars, twin quakes, and overhead, unseen by human eyes but tracked by satellites, our sun was launching enormous magnetic storms. Solar forecasters at NOAA's Space Weather Prediction Center were watching coronal mass ejections, billion-ton clouds of plasma ripping away from the sun at over 1 million miles per hour. Their models hinted these solar storms were crossing paths with something unprecedented. 3I/ATLAS, the third confirmed interstellar object to ever enter our solar system. The timeline borders on theatrical. Novae, quakes, solar storms, all clustering between September 23rd and 25th. And right in the middle of it, an alien visitor threading through the inner solar system during one of the most active phases of solar cycle 25. This isn't just happening across neighborhoods. It's happening across scales that defy intuition. Light from the novas had traveled thousands of years to reach us exactly this week. The Venezuelan earthquakes happened in a region where two tectonic plates grind against each other, a stress zone waiting to rupture. The coronal mass ejection spanned a region larger than Jupiter's orbit. And 3I/ATLAS? It was crossing the ecliptic plane, the thin disk where most planetary action occurs, threading between Mars and the Sun. No one is claiming a causal link here. That would be reckless. But documenting the convergence matters. Mainstream science tells us there's no proven connection between space weather and earthquakes. Solar physicists call CMES routine. Stellar astronomers see novas as expected outbursts of binary star systems. Yet this week is unique. 3I/ATLAS is not just another comet. It's only the third interstellar object ever detected. After Oumuamua in 2017 and Borisov in 2019, and the first time we're watching one up close during a period of intense solar weather. Part 2. Two stars explode. In the pre-dawn hours of September 23rd, amateur astronomer John Sesh was scanning the southern sky from his observatory in New South Wales. What he found would ignite a frenzy across the astronomical community. A star that had been invisible to the naked eye suddenly flared at magnitude 5.8 in Centaurus. Within hours, gamma-ray and X-ray observatories swung into action. NASA's Fermi Gamma Ray Space Telescope detected high-energy photons streaming from the nova. Swift's X-ray instruments picked up hard radiation, the signature of particles accelerated to near light speed. Days later, lightning struck twice. V 7994. Sagittarius erupted at magnitude 6.2, also in the southern sky. 2 naked-eye novas in a single week, an astronomer's dream, and a rarity even in a galaxy that averages a dozen novas per year. The physics is as dramatic as the visuals. Each nova begins with a white dwarf, siphoning hydrogen from a companion star. Over years or centuries, the gas builds up until it ignites in a runaway thermonuclear blast, brightening the system by tens of thousands of times. The white dwarf survives, but its stolen fuel is hurled into space at thousands of kilometers per second, creating shock waves that twist magnetic fields and accelerate particles. These novas lit up precisely the region of sky where southern observers could see them best. And within hours of Sech's reports, international astronomers were gathering photometry and spectra, measuring light curves and emission lines to decode the explosions in real time. No, novas this far away don't influence Earth directly, but the timing, 2 bright stellar blasts during a week of intense solar storms and major quakes, is undeniably striking. Sometimes the universe writes poetry in the language of physics. Part 3. Venezuela shakes. Twice. At 22:21 UTC on September 24th, Venezuela's Zulia state released energy equivalent to several nuclear weapons. The 6.2 magnitude quake, shallow and violent, sent shockwaves across both Venezuela and Colombia. Just 5.5 hours later, another rupture, magnitude 6.3, struck virtually the same spot at greater depth. Combined, the twin quakes released energy on par with a magnitude 6.4 to 6.5 event. Aftershocks followed, including a magnitude 5.8 tremor later on the 25th. The region's complex tectonics make it a natural stress zone. Here, the Caribbean and South American plates grind past each other along a web of faults. Stress builds silently over decades before snapping without warning. The depth difference mattered. Shallow quakes produce stronger surface shaking than deeper ones of the same magnitude. Residents across Maracaibo, Caracas, and Colombian border towns posted videos of swaying buildings and shattered windows as emergency crews scrambled into action. No proven mechanism links solar storms or novas to quakes, and USGS maintains that correlations are unproven. But to the public, the timing was unsettling. Another echo in a week of cosmic and terrestrial upheavals. Part 4. The Sunfires and an Alien Visitor. While the ground shook, 93 million miles overhead, the sun was staging its own outbursts. Coronal mass ejections, giant eruptions of plasma and magnetism, were streaming across the inner solar system during those same days. And, for the first time in human history, one of these solar storms appeared to be on a collision course with an object from another star. 3I/A/TLAS, discovered only 2 months earlier, is threading the ecliptic plane at an angle that makes it far more exposed to solar weather than previous interstellar visitors. We've seen CMEs rip ion tails off comets before. The 2007 disconnection event of Comet Encke is textbook physics. But we've never watched our sun interact with material formed in a completely different stellar nursery. If model forecasts are right, late September's solar storms may have brightened 3I/A/TLAS's coma, altered its ion tail, or released new molecules from its icy surface. Amateur astronomers worldwide are already comparing images night after night to catch any changes. This is more than a curiosity. Documenting how our sun reshapes interstellar material could teach us how stars across the galaxy influence the travelers passing through their systems. 3I/ATLAS is scheduled to sweep past Mars on October 3rd at just 28 million kilometers. By late October, it will reach perihelion, its closest approach to the Sun, and by December 19th, it will be closer to Earth than Mars ever gets at its farthest point, an unprecedented window for observation. Part 5, Weirdness Framed. Step back and look at this map. 2 novas bright enough for the naked eye. 2 major earthquakes in one region within hours. An interstellar visitor swept by a solar storm at solar maximum, all in the last week of September 2025. Science tells us these are unrelated, but human pattern recognition can't help but wonder. Sometimes the universe clusters its dramas so tightly that coincidence starts to feel like choreography. Our promise to you: we'll separate what's confirmed from what's speculative. We'll give you both the clean science and the bold what-ifs, clearly labeled, because you deserve to know which is which. The data matters. The wonder matters. And sometimes the most honest thing science can say is, we don't know yet, but we're watching. So, as 3I/ATLAS speeds toward its Mars flyby, as the novas fade and the aftershocks settle, we're left with a picture of a universe far more dynamic and far more interconnected than we usually imagine. Stay tuned, because the story of September 2025 isn't over yet.